Welcome to file compression and file hashing. In this video, we're going to look through a bunch of the different compression techniques in the RTFM. We're going to pick one of them to run against a big file, and we're going to see what we get. And then we're going to wrap this video looking at file hashing and why it can be important during a red team assessment. It is really important to be familiar and just be able to work around and use a bunch of these different tools. We have some different tar commands, gzip commands, zip commands. There are a ton of different compression utilities on Linux, but they're not always all there on the different distributions. Depending on what customer system Linux distribution you're on, you could only have access to maybe just the tar commands, right? Or just the gzip command. So just be ready to use any of these out of the RTFM in different circumstances you may be in. So I'm gonna go ahead and try to use this zip command right here. So we have zip tac r, output file should be pretty straightforward here. So let's do zip tac r. Our output file we're gonna call output.zip. And then we have an input path here. I'm gonna give it that huge file I created in the last video. Actually, let's do ls.alh. We have our giant file here, 300 megabytes. This is not an actual text file, so because it's random data, it's encrypted data, I don't think it's gonna compress at all. But let's go ahead, let's see if it works here. So we'll do our zip tac r, our output files, output.zip. And then it says input path. So let's do test file .dat. Adding should take a while. This is a huge file. Let's see what happens. Okay, I think it's done. Let's do an ls.alh. Output zip right here. And like I said, it's UDEV random, so there are no patterns. It's not text. It's not going to compress at all. But we were able to test our zip command. It did output as output.zip. And it looks like to unzip it, we'll just type unzip. Actually, first let me create an export directory. We'll move our zip to export, cd to export. And then we'll do our unzip output.zip. It's inflating it. If I do an ls.alh, original file right here worked really well. UPX is an extremely popular packer. It'll just obfuscate and pack things. It is extremely well known these days, so don't think you can just run UPX against something and it's gonna all of a sudden bypass a bunch of different antivirus. Definitely keep that in mind, but if you do need to run it against something, your command's right here. So I've got our split command already configured here. We're gonna take in the file, and this is the big 300 megabyte file we created in the previous video. We're gonna zip the chunks, split it out to, and then we're gonna pre-append myzip.chunk. Let's go ahead and fire it off. And while this runs, I did want to mention, this can be really helpful if you're exfiltrating really large files from a customer network. You can potentially break a 1 gigabyte file down into 100 megabyte chunks and then just slowly bring it back over time, rather than that massive file that, you know, if anything happened while it was transferring, you'd lose the whole thing, which would be horrible. And you can split it out over multiple weeks if you really want to lower your C2 traffic coming out of the network. That would be way less easy to spot. Looks like it works successfully here. Let's do an ls. You know it's bad when it's taking a while. Yep, there's all my chunks, tons of chunks. Prepended, looks good. And now I want to quickly jump into file hashing. The whole concept behind a hash is that if the source file changes even a little bit, the hash is completely different. So it's kind of a unique fingerprint of a specific file or string or whatever you want to call it. So let's test that. Looking at the table over here, we have a bunch of different ways to do our hashes. We're going to do a SHA-1 sum of file1.text. Now, if I nano file1.text here and I just add 1 T, the hash should be completely different. Yeah, look at that, not even close, completely different. So running a hash algorithm against specific files ensures that you're getting the file that the author meant, that it wasn't tampered with in transit. You're gonna see a lot of different software developers that offer up these files for download. They actually post the MD5 sum for that specific file. That way, when you download it, if it's different, you know it's been tampered with. And you can also run these hash algorithms against files before you download them from the host. That would ensure that they weren't corrupt in transit. And that's the end of this video. I hope you enjoyed the look at compression, file chunking, hashing, and just kind of the importance behind that stuff. In the next video, we'll be jumping in with Linux persistence methods. Definitely really, really exciting. So click through to that one and we'll see you there.